Hey, this is Steven from the Green Engineers, and welcome to my product highlight of the Reclaimer, which is soon to be in mass production here. So, you guys have seen something like this before. Here is my original version. Let me move some of the stuff out of the way. So, here's a side-by-side of my original version versus the new version. Now, a couple things have changed. Obviously, you see the mistake here that when I originally had this water jetted by my university, the teeth, he accidentally nested the same blade 24 times. So the teeth are basically in the same, so I have half of them rotated 90, half of them straight. So there's too many that are going to engage at once here. This one also had an issue that when the blades rotated, they hit the spacers on the inside, so the spacers would actually prevent it from rotating fully. And this guy also used a 3/4 inch drive shaft. There we go, 3/4 inch square with 6,000 ZZ. What is it? 6,000 ZZ ball bearing on the inside. One here, one here. And it uses square to circle converter discs in there as well. So this guy was water jet cut, and it was made out of 1045 steel. 1045 steel, and the shafts were 1055 steel. So that is hardenable steel. So this one would have been able to be hardened if need be. Now going to this guy. So this guy is laser cut from one of my suppliers that now is going to be helping me with this project. So this is brand new. I just put it together yesterday, and I just finished welding it, and you can see I was adjusting the heat. So these ones here were too low a power, so I bumped up the power and got them thicker welds, so I used that to secure them even better. So now I got thicker welds here. You can see that it has the blades on there. And another issue with this one was that I was messing around and I wanted to see if it was possible. I asked for 0 backlash gears to be made, and they actually work. But they work a little too well. So if you look in here, you'll notice that the blades are contacting both. The gears contacting both at the top and the bottom. So there is no like looseness here. They're perfectly meshed. So this is something like a CNC machine would have, something that you need high accuracy with. Now on these, you can see that if you zoom in on my new version, because obviously that's unnecessary. We don't need that. So you can see here on this version that if you look in really closely, the gears are not touching. So you could actually get a little bit of play out of it, and that's perfect. So now there's not as much friction there. So now you also notice that here the blades are now progressing correctly. So each set of blades is rotated 15 degrees inwards. So when you're turning the blades, it actually will contact in only one place. Obviously, I'm turning it backwards. So this is forwards. As you can see there, it rotates forwards. Now, I do have to, so this is my sample. I'm going to have a run done of 8. So I'm going to have a total of 9 total, and then this one will stay with me. Now, as you can see, I got a little bit of tolerance stuff to work on. These I want to tighten up a little bit. So I'm going to change their tolerance to make them a little bigger so they fit a little more snugly in here. So I'm going to do that. As you can see, they're pretty loose. They're really loose. So I'm probably going to make this closer. Actually, no, I don't want to make it closer because then it'll hit this back wall. So I'm just going to make these on the higher side of the tolerance. And then I have another issue, which is when these blades come down, it actually hits the floor. So what I need to do is I need to make this wall the plus side of their tolerance. So these walls are actually taller. And then I made another mistake that I fixed on this one, but I completely forgot about, which was I made these walls were originally supposed to go on the inside, and I remembered that that wasn't going to work, and they actually need to be on the outside in order for the blades to clear. So I had to make some new ones, and that's where I tried my drill press that you just saw in my update video, and so that's good. So this is what the side looks like. Obviously this is a 6-inch piece, but in actuality that sidewall is going to be 6.5 inches long. That's what this one is. There's going to be 4 holes. Top 2 are for the hopper attachment, and the bottom 2 are for the stand. So you could buy a stand from me, manufactured by hand, and the hopper, which is laser cut and then hand bent by me. So you could buy those two you buy those 2 expansion modules that I'm currently working on. And also between these 2 holes, what's going to be shared is it's going to have a mount for a motor, for a high torque motor to drive this guy. I'm thinking the best way to do it is to run with a cheap Harbor Freight drill. It's a high torque spade drill that has 600 RPM, and I'm going to step it down by 4 1/8 times, I believe it is. So I'm going to step it down to what is like 4 1/8 times, I think it was something like that. 4 1/8 times, 4.18 times, 4.125. So I'm going to decrease the speed and increase the torque. So this guy will rotate about 100 and I think it was like 120 RPM or something like that. My target was 30. We might do that. I might have multiple options for it. So one option is you put a bigger step down gear on it to increase torque but lower the RPM for higher torque and necessity applications. So there's going to be that. I'm also going to be working on a stainless steel option, but the stainless steel option is going to be considerably more expensive. Before I start selling these, I'm going to have those priced for the what's the word I'm looking for? For the quote. So I'm going to have those quoted, and so I'll be able to give you guys a comparable pricing for that, so you can make the decision beforehand. And then eventually, I'm going to have a higher carbon steel version, which is hardened or pre-hardened material. I'll probably go with pre-hardened because it's easier to keep dimensions. So probably pre-hardened steel that's surface, so it's nice and flat, and then they will laser it. But that will be considerably more cost than the regular steel and the stainless steel one. So that one's later on. That one's going to be for really thick, hard plastics. And then eventually I want to work on a larger format one, but again, that's going to be considerably more expensive. So right now, if this guy is a 6-inch by 6, so 6-inch this way, well 6.5, but this opening is 6 inches, and then this is also 6 inches. So 6-inch by 6-inch by 3.5, and then this opening is, I think it was like 4 inches or something like that. It's about 3.5 inches. So technically you could load in something about 3.5 inches and eventually it will go through it in here. And you see it's got progressing, so you could either buy this and put it on a table and use these 2 bottom bolts and a angle iron and bolt it down to a table and use a jigsaw and just cut a square in the bottom of the table and put a bucket underneath it and then work it by hand. I'm thinking about possibly supplying a laser cut 1/2 inch or like 3/8 thick large 3/4 inch wrench, which would probably be like 14 inches long, 14 to 16 inches long. So this one, so yeah, I think it's like 14 inches long. So you can see here that this is like 9 1/4. So it'd be another couple inches, and that's probably all you'll need for this guy to shred bottles and do all that kind of stuff that you want to do. So yeah, so this guy, I'm gonna have those 8 available pretty soon. I'm gonna finalize everything with this and get all the tolerances right and send out the order. So within the next couple days, I plan on having that happen, and then they'll be in about 10 days, and I'll have it up on my website. I might be overhauling the website to be ready to get these guys into the market. So be looking out for that. When they're shipping, as they're cutting it, when they're working on cutting it, I'm going to work with them to get a quote on stainless and pre-hardened material, and so you guys could see a comparison of that, how much that would cost, and also a idea of how much something that's twice the size would cost. So I will do that as well. I'll tell them, hey, how much would it cost for a shredder that's twice the size, which is going to be my next one, is probably 12 by 12 or so, but I'll try to get to you guys the some of those comparisons for that price as well. Alright, thank you guys for watching, and I will see you guys in the next one. Take it easy. Peace.